welcome back, geometry students, to another Regents review video. This is the June 2015 Regents exam for Geometry Common Core. These are going to be the solutions to the Part 1, questions 13 through 24. Please, if you are here to copy my answers, please refrain from doing so because the Geometry Regents is very difficult. But if you're here to check your answers, that you did it already, fantastic, you've come to the right place. All right, without further ado, let's go ahead and jump right into this. We are going to do question number 13, starting off with this. Here we go. So question 13 says, quadrilateral ABCD has diagonals AC and BD. Which information is not sufficient to prove that ABCD is a parallelogram? Well, you need to know how to prove things to be a parallelogram. And this is what you need to keep in mind. If we have a parallelogram, which I'm going to draw one right now. If we have a parallelogram, you could prove a parallelogram in the following ways. You could prove two pairs of two congruent opposite sides. So if the opposite sides are congruent in a parallelogram and there's two pairs of them, it is a parallelogram. You could also say that if you have two pairs of two parallel sides who are opposite each other, that could also prove a parallelogram. If a quadrilateral has one pair of congruent and parallel opposite sides, that could prove a parallelogram as well. And of course, just some miscellaneous information, opposite angles in a parallelogram are congruent and consecutive angles are supplementary. Just to know all the basic properties of a parallelogram. So now if we look at the answer choices, let's take a look. It says here that AC and BD bisect each other. Well, let me just get rid of all this stuff and I'm going to start labeling. So we have A, B, C, and D. It says that AC and BD bisect each other. Well, and I did forget to mention this, do diagonals in a parallelogram bisect each other? Absolutely they do. They definitely bisect each other. So that proves a parallelogram. We're trying to find the one that's not sufficient to prove that it's a parallelogram. Choice 2 is saying that AB is congruent to CD and BC is congruent to AD. Do two pairs of two congruent opposite sides prove a parallelogram? Absolutely they do. That definitely proves a parallelogram. Let's take a look at choice 3. AB is congruent to CD, and then AB is parallel to CD. Does that prove a parallelogram? Can one pair of congruent and parallel sides who are opposite each other prove a parallelogram? Absolutely they can. Your answer is going to be choice 4. And choice 4 is a little tricky to explain, but I will do my best, of course. Now, I just drew what's called an isosceles trapezoid. Choice 4 shows what's called a counterexample. And a counterexample is just a different quadrilateral that has the exact same properties as what's described. So I just drew an isosceles trapezoid. By definition, an isosceles trapezoid, their bases or their non-parallel sides are congruent and their bases are parallel and their legs are congruent. So AB is congruent to CD and BC is parallel to AD. That's true for the isosceles trapezoid. So choice 4 is not enough information to prove this to be a parallelogram because by definition, a parallelogram is a trapezoid, but a trapezoid is not a parallelogram. So that's why it's going to be choice 4. All right, number 14. Completing the square is on every single geometry reading exam. Devote this to memory. You learned this in Algebra 1. Sorry, I can't speak tonight. The equation of a circle is x squared plus y squared plus 6y equals 7. What are the coordinates of the center and the length of its radius of the circle? So, I'm going to rewrite this down below, and I'm going to get started. So, in order to complete the square, you keep your letters on one side of the equation and numbers on the other side of the equation. We have all letters, numbers on the other side. Perfect. So now, in order to complete the square, your job is to create a perfect square trinomial. using the linear term. Now, I'm going to put in a blank space after the y, and what you do to one side of the equation, you must do to the other. That is the golden rule of algebra. What you do to one side, you must do to the other. Now, how do we solve for this? Now, remember, your goal is to create a perfect squared trinomial. You can only do it on the y terms. You can't do it on the x term because there's no linear term. The linear term is the middle term. That's what's called a linear term. Now, we use the linear term to determine the value that goes in the this line or the box. And in order to do that, you need to use the formula b divided by 2 squared. B divided by 2 squared is you take half the middle, 6 over 2, and then you square it. 6 over 2 is 3. 3 squared is 9. So you put 9 in for each. Perfect. Let's keep going. Now, what do we do from here? Well, now we have a trinomial. We could factor all trinomials. What adds to positive 6 and multiplies to give you positive 9? Well, that's going to be y plus 3, y plus 3. And what's nice about completing the square is you always get the same binomials. These are always the same in completing the square. And that x squared carries along for the ride. 7 plus 9, that is going to be equaling 16. Now, there's another way to write y plus 3, y plus 3. We could combine these and get y plus 3 squared. And that, again, x squared carries along for the ride, and we get 16. This is what we want, ladies and gentlemen. This equation right here is called the center radius form of a circle. And we could easily determine the center and the radius of the circle. Your center is going to be 0, negative 3. And your radius is the square root of that number, which is going to be 4. You take your opposite of the values inside here to get your center, and the radius is the square root of that larger number, which is 4. Now, if we go back to our answer choices, the correct answer is going to be choice 2. The center is 0, negative 3, and the radius is 4. That's question 14. Moving on to 15. Triangles ABC and DEF are drawn below. If AB is 9, BC is 15, DE is 6, EF is 10, and the measure of angle B is congruent to the measure of angle E, which statement is true? Okay, so the first thing that I want to look at first is, are these two triangles similar? Well, they certainly do look similar just by looking at it, because remember, similarity means same shape, different size. But we don't know for sure. We have to verify it. So I am going to set these in proportion. Is 6 over 10 equal to 9/15? Is that the exact same fraction? And yes, it is, because 6/10, if you plug that into your calculator, if you plug in 6/10 into your calculator, you get 3/5. And if you plug in 9/15, you also get 3/5. So therefore, 3/5 is equal to 3/5. So we're good. Now, this angle in the middle that you see here, that's what's called an included angle. So if we have two sets of sides that are in proportion, and we have an angle in the middle that are congruent, we could prove these two triangles by side angle side similarity. Now, if we go back to the question, it's saying which statement must be true. Of course, it's going to be choice 3. Triangle ABC is similar to triangle DEF. That's all we know about those two triangles, and we know for sure that that can be proven. All right, 16. If triangle ABC is dilated by a scale factor of 3, which statement is true of the image triangle A prime, B prime, C prime? So what you have to do is draw. Always draw. Draw a triangle and call it ABC. Now, our job is to dilate this by a scale factor of 3, and I'm just going to do a pretty rough sketch of this. That could be a scale factor of 3, probably. Now, this is triangle A prime, B prime, C prime. Now, which statement is true? Now, the language here is really important. If we go through all of the answer choices, by the way, there's 2 answer choices in this that are completely and utterly false, that they try to trick you every single time. And the answers, choices 3 and 4, those are always wrong. Those 2 answers are wrong because they're manipulating the angles. What's going on here is this is a dilation. And you have to know that a dilation preserves angle measure. What they're doing here is they're suggesting that the angle measures are manipulated. Choice 3 says that the measure of angle A is equal to triple the amount of the measure of angle A. No, that can't work because angle measures are preserved under a dilation. Same thing down here. They say if you take C prime, the angle C prime, and multiply it by 3, that will equal angle C. No, absolutely not. Dilations preserve angle measures. So we're focused right here on choices 1 and 2. Dilations don't change angle measure. By the way, make sure that you're copying everything down to correct your work if you are correcting it. If you're here to copy, you're in the wrong place because geometry Regents is hard. Now, let's take a look at 1 and 2. Now the language is hard. What this is saying is it's saying that if you take line segment A prime B prime, the distance of A prime B prime, and you triple it, does that equal AB? Absolutely not. If you take a bigger segment and make it larger, that's going to equal this little guy over here. Can't work like that. So 1 is wrong. The answer is choice 2. B prime C prime is equal to triple the length of BC. Perfect. That's your dilation with a scale factor of 3. If you take BC, side BC, and dilate it by 3, it's going to give you side length B prime C prime. So that is the correct answer, choice 2. 17. Steve drew the line segments A, B, C, D, E, F, G, B, F, and C, F as shown in the diagram below. Scaling triangle BFC is formed. Which statement will allow Steve to prove that line ABCD is parallel to line EFG? Okay. We need to remember that there are 4 ways to prove lines parallel. The first way is to prove it by alternate interior angles that are congruent. That's the first way. The second way is alternate exterior angles are congruent. The third way is corresponding angles are congruent. And last but not least, the fourth way is if you have same side interior angles that are supplementary, meaning that they add to 180 degrees. So if you could prove any one of those, the lines are parallel. Well, if we go back to our question, it says, how do we prove these 2 lines parallel? Well, let's take a look at choice 1. Choice 1 is saying that the measure of angle CFG, so CFG, which is over here, is congruent to FCB. FCB. Whoa, wait a minute. That's a Z. Now, your geometry teacher could have taught you the Z formation. These 2 angles are alternate interior angles. So choice 1 is showing alternate interior angles that are congruent. Is that one of the ways that could prove lines parallel? Yes, it is. It's right there. So that is going to be choice 1 for number 17. All right, number 18 is definitely tricky. It says, in the diagram below, CD is the image of AB after a dilation with a scale factor K centered at E. Be careful. CD is the image. So that means that your scale factor K has to be less than the number 1 because it's getting smaller. Which ratio is equal to the scale factor K of the dilation? Now, what you need to know about a dilation is that you could create similar triangles. So what I'm going to do is I'm going to create 2 similar triangles on this graph. I'm going to create triangle CDE, and I am going to create triangle ABE. I should have really made that. I apologize for that. That should be red underneath. I'm not so sure why it's... There we go. Let me just move this a little bit here, just so you can clearly see the difference. Having some difficulty moving this. All right, let's just leave it right there. Okay, so these 2 triangles are similar because there's a dilation going on. So in order to complete this question, we need to figure out, well, if we have 2 triangles, what's the scale factor? Well, the scale factor, again, has to be less than the number 1. If we look at our answer choices, the first one says EC to EA. So is EC to EA, does that suggest that a scale factor is less than 1 and that is a scale factor because it's in proportion. Is that true? Yes, it is. Your answer is going to be choice 1. Once again, I'll tell you why. EC, the distance of EC is less than the distance of EA. So therefore, your scale factor immediately is less than the number 1 because this fraction is less than the number 1. And EC is in proportion to EA. So therefore, that would be your scale factor. All right, number 19. A gallon of paint will cover approximately 450 square feet. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the entire cube? So what you need to know is, what's the surface area formula of a cube? Now look, they really don't test this often on the Regents, but it is beneficial to know the surface area formula of a cube, just in case they ask for it on another exam. All right, I'm going to draw a little dotted line behind here just to show it. The surface area of a cube is 2 length width plus 2 length height plus 2 width height. Now, a cube, all edges are congruent in a cube. So this is 12, this is 12, this is 12. So if I take my surface area and I plug in 12 for each, I will get my surface area. So 2 times 12 times 12 plus 2 times 12 times 12 plus 2 times 12 times 12. Now, if you plug that into your calculator, just take my word for it, you're going to be getting 864. Now, the question is asking you how many cans of paint does this person need? 1 can of paint could cover 450 square feet. Well, all we have to do is we just take our surface area, which is 864, and divide it by the amount of square feet 1 can of paint paints over. So that's going to be, let's see what that is. 864 divided by 450. Decimal point, 1.92. So it takes exactly 1.92 cans of paint to paint this cube. Problem is, the last time I went to Lowe's or the Home Depot, cans of paint do not come in 0.92 cans. So you need 2 cans of paint to paint the entire cube. Of course, will you have paint left over? Yeah, of course you will. But you do need 2 cans of paint to complete the job. All right, number 20. In circle O shown below, diameter EC is perpendicular to CD at point C and chords AB, BC, AE, and CE are drawn. Which statement is not always true? So, you really have to know your circle theorems to get this question right. Let's take a look at number 1. The measure of angle ACB, so this angle over here, is congruent to the measure of angle BCD. Is that always true? Maybe. I mean, I'm not 100% sure. So let's keep going through these answer choices. Number 2. Angle ABC is congruent to angle ACD. All right, are those 2 angles congruent? Well, just by looking at them and based on my knowledge off of circle theorems, they are congruent. And let's talk about why they're congruent. Angle ABC is inscribed in a semicircle. When you have an inscribed angle inscribed in a semicircle, this angle right here, I'm going to change this. This angle right here is a right angle because it's intersecting or intercepting a semicircle. So this is the arc it's intercepting. That's a semicircle. A semicircle has 180 degrees. An inscribed angle is 1/2 the arc it intercepts, so therefore this is 90. Now, this angle over here that you see, angle ACD, that is also a right angle because it says right here in the instructions, AC is perpendicular to CD. So therefore, angle ACD is a right angle. So those 2 angles are congruent to each other. Perfect. So we know that that's wrong because we're looking for the one that's not always true. Number 3, the measure of angle BAC is equal to or congruent to the measure of angle DCB. DCB. So that's right here. The measure of angle BAC is inscribed. The measure of angle DCB, it is the property of a chord and tangent intersection. When you have a chord and a tangent intersecting at a point, it is 1/2 the arc it intercepts. So therefore, if you have two angles that intercept the same arc, they are congruent because this angle over here is inscribed, so it's 1/2 the arc it intercepts, and this angle over here is 1/2 the arc it intercepts. So therefore, choice 3 is always true. Let's keep going. I'm going to clear this off a little bit just so it's a little bit neater. And choice 4, the measure of angle CBA is congruent to the measure of angle AEC. Is that always true? Yes, it is, because the measure of angle CBA intercepts a semicircle. The measure of angle AEC intercepts a semicircle as well. So therefore, these two angles are in fact right angles. So therefore, your answer is going to be choice 1, and the reason why is they never, ever, ever said that BC is a bisector. So this is an assumption, okay? Because it never said that BC is a bisector, all right? That one was definitely a step up in difficulty level. Moving on to question 21. This one is ridiculous. In the diagram below, triangle ABC is similar to triangle DEF. All right? If AC is 12, DC is 7, DE is 5, and the perimeter of triangle ABC is 30, what is the perimeter of triangle DEC? Okay. You need to know that if two triangles are similar, that their sides and perimeters are in proportion. That's what you have to know. So, if we know that their sides and perimeters are in proportion, we could set these two triangles in proportion. The 7 and the 12 are the ones that are in proportion. Believe it or not, you're not even going to use this 5 in this problem. It's kind of there just to screw with your head a little bit. So what we do is we're trying to find the perimeter of triangle DEC, right? It has to be in proportion. So if I do 7 over 12, I'm going from the small triangle to the big triangle. I then have to go from the small triangle to the big triangle again. So the perimeter of the smaller triangle, I'm going to call that x. I don't know what it is. And the perimeter of the larger triangle is 30. 7 times 30 is 210 when you cross multiply, and that's equal to 12x. When you divide by 12 on both sides, you get x is equal to 17.5, which is going to be choice 4. All right, moving on to question 22. So, question 22 says that the line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? So, the first thing that I want to do is I want to put this equation in y equals mx plus b form. And you'll see why in a moment. So in order to begin that process, you divide everything by 3 because you want y by itself. You get y is equal to negative 2/3 x plus 8/3. Okay? Now, why am I doing this? Well, we're dilating a line. When you dilate a line, when you dilate a line, the slope remains the same. So I want to look for an answer that has the same slope as this line right here. Okay, I want to find that same slope. Well, the slope of this line, we just concluded that the slope is negative 2/3. Perfect. Let's go through each answer choice and figure out which one has a slope of negative 2/3. Well, let's take a look at choice 1. If we take a look at choice 1, we get 2x plus 3y is equal to 5. Put this in y equals mx plus b form. I'm going to subtract that 2x on both sides. You get 3y is equal to negative 2x plus 5. And then you just divide by 3 on each side. And you get y is equal to negative 2/3 x plus 5/3. Hey, wait a minute. That's negative 2/3. But that matches. So that's the answer. Perfect. We're done. Choice 1's the answer for question number 22. All right, question 23. This one was interesting. It says here, a circle with a radius of 5 was divided into 24 congruent sectors. The sectors were then rearranged as shown in the diagram below. To the nearest integer, the value of x is what? So, we need to figure out what's going on here. First of all, it has a radius of 5. Well, I want to talk about what the diagram's showing. It looks like, when I teach my students this, I say that this is a pizza pie, divided into 24 slices. For some unknown reason, I don't know why, but for some unknown reason, they decided to say, you know what, we're going to give some more, we are going to give people pizza and split this pie down the middle. We are going to give 12 slices to the parents and 12 slices to the kids. I don't know why they did that, but they wanted to slice it in half. And they continue to slice it, and then they're like, you know what? It is served much easier if you just squish the slices together. Again, I don't know why they're putting these together, but whatever. We're not going to get fooled by New York State. We could do this. We're trying to find x. Well, what is x measuring? X is measuring half of the circumference. Yes. Circumference is the perimeter of a circle. And the reason why I use air quotes is that it's really improper to say perimeter of a circle, but that's what circumference is. It's the length around a circle. So x is showing half of the circumference. Why? Well, this is the entire circumference. It's being split in half. That's half of the circumference. That's half of the circumference. And this is half of the circumference. So circumference, the formula for circumference, and it's actually on your reference sheet, the formula for circumference is 2 pi r. C is equal to 2 pi r. I don't use pi times the diameter. I don't like that one. I use 2 pi r. All right? So if we know that that is circumference, we could solve for it. Pretty simple, right? So the circumference is 2 pi times the radius of 5. That's equal to 10 pi. Well, 10 pi in your calculator is equal to 31.415. Well, that's not the answer, though. That's a trick answer, because that is the entire circumference. That's the pink up here. We're trying to find the blue. To find the blue, we need to divide by 2, and we get, well, we divide that answer by 2, we get 15.7. So that's 15.7, which is approximately equal to 16. So that is going to be choice 2 for question number 23. Final question on the multiple choice. You made it. It says, which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? Well, we need to know the 5 ways to prove triangles congruent. And here are the 5 ways to prove triangles congruent. We could prove triangles congruent by side, side, side. Side, angle, side. Angle, side, angle. We could prove it by angle, angle, side. And last but not least, the one that everyone usually forgets is hypotenuse, leg. Well, we cannot prove hypotenuse, leg in this because it does not say anywhere in the instructions that triangle DEF and triangle ABC are right triangles. So what we have to do is we have to go through each answer choice and figure out which one of these 4 would work. So, number 1 is showing that AB is congruent to DE and BC is congruent to EF. Well, that's cool, but that's side, side. You can't prove triangles congruent by side, side. It has to be side, side, side. But that's not showing it. So choice 1's wrong. This, choice 2, is showing that angle D is congruent to the measure of angle A. Angle B is congruent to the measure of angle E. And angle C is congruent to the measure of angle F. That is showing AAA. You cannot, under any circumstances, prove triangles congruent by AAA. You don't need roadside assistance. You don't need AAA. So choice 2 is wrong. By the way, roadside assistance, AAA, that's a company, if you're curious. That was a joke. All right, number 3. There's a sequence of rigid motions that maps AB. All right, let me clear out these diagrams because they're getting a little messy here. There's a sequence of rigid motions that maps AB onto DE, BC onto EF, and AC onto DF. This is showing side, side, side. Is that sufficient to prove triangles congruent? Yeah, absolutely they are. Perfect. Now, just because choice 4 is, it confuses people. If you pick choice 4, you fell in the trap. And I want to go over it right now. There's a sequence of rigid motions that maps point A onto point D, point A onto point D, AB onto DE, and angle B onto angle E. You cannot believe how many people thought that this is showing angle, side, angle. No, it is not, ladies and gentlemen. And the reason why is for this vocab word right here. Point. Point A. There's no such thing in the mathematical universe of point side angle. A point, by definition, has no depth, no length, no width, no distance. So that can't be an answer. So the choice 4 was the trick answer in that question. All right, that is the conclusion of this video. Please subscribe to my YouTube channel. Please visit my website at www.nysmathregentsprep.com, and you'll find a whole bunch of Regents Review resources and geometry resources on that website. And I will see you in some future videos. All right, see you, folks.